Up until this moment, we've talked about randomness. Now we're going to change our thoughts to actually probability. No more looking at random outcomes. We're looking at what's the probability that this outcome can occur. There are rules of probability. Rule number 1. And if you take a math proofs class, you'll see lots and lots of rules. So this is set up just like that. If the probability is 0, then that means the event never occurs. And likewise, if it has a probability of 1, that means it always occurs, or it definitely is going to occur. If you think an event is unlikely, its probability cannot be negative. It's just going to be closer to 0. And if you think you're sure it will happen, its probability can't be greater than 1. Typo. So a probability is a number between 0 and 1. For any event A, my probability will fit in between those numbers. 0 meaning will definitely not occur. 1 meaning it definitely will occur. Has to be in between here. So there's no way you can say I have a probability of 1.5%, 110% sure I'm going to graduate. Sorry to be negative Nancy there. Rule number 2. The first thing to be sure of is what we distribute to all of the available probability. Something always occurs, so the probability of the entire space is 1. This is called the probability assignment rule. So the set of all possible outcomes of a trial must have a probability of 1. So like I said, between 0 and 1. So if, let's say, you have a 0.98% chance of graduating, then what's your chance of not graduating? What's that? 0.02. Yes, they must equal to 1. So your probability range, whatever your probabilities are, they must total to 1, or 100%. If they total anything other than 1, something's wrong there. Rule number 3. Suppose the probability that you get to class on time is 0.8. What's the probability you don't get to class on time? Yes, it's 0.02, because they must equal to 1. So the set of outcomes not in event A is called the complement of A. So you can see this, A to the C power, that's the complement of A. That means it's likely not to occur. The event of A is likely not to occur to this probability. That's called the complement rule. So the probability of an event occurring is 1 minus the probability that it doesn't occur, or vice versa. So the probability of an event not to occur is 1 minus the probability of that event to occur. Just like we did here. 80% chance of getting to class. I know I have a max of 1, so subtract that. Disjoint, or mutually exclusive. Events that have no outcomes in common. So here's a vocabulary word that's going to help us in the next rule. Disjoint. Event A does not affect event B. They're disjointed. Rule number 4. Suppose the probability that A randomly selected student, is a sophomore, is 0.2. And the probability that B, that he or she is a junior, is 0.3. What is the probability that the student is either a sophomore or a junior? Written as this, P-A-U-B. You probably remember seeing this in Algebra 2 with compound inequalities. Or means the union. So, if you said 0.5, so what you did was you took, what's the probability of him being a sophomore? That's 20%. Probability of that person being a junior is 30%. Then the probability of him being one or the other is 50%. You deduce the addition rule. So you added them together. So for two disjoint events, A and B, the probability that one or the other occurs is the sum of the probabilities of the two events. Like so. Again, they must be disjointed. One must not be affecting the other to happen. Suppose that 20% of people have a dog, 30% have a cat, 10% have a bird, 5% have a fish, and the rest don't have pets. What is the probability that someone owns a bird or a cat? So first off, bird, as a decimal, what's my probability? The bird, 0.1, 0.1, 10%. What's the probability of someone having a cat? 0.3. Would you say these are disjointed? If someone has a cat, are they more likely to also buy a bird? And vice versa? No. So these are separate. So what's the probability of this or this happening? Which means I'm adding the two. Which I get what? 0.4. So if, for today's Schoology, please leave this as a decimal. Don't change this to 40%. Leave it as 0.4. So I have a 0.4% chance that someone owns a bird or a cat. Here's where your brain explodes. Suppose that 19% of people have a dog, 20% of people have a cat, 11% of people own both. What is the probability that someone owns a dog or a cat? This is where I say start drawing pictures. So let's say my set A is a dog. How many percent of people have a dog? 19. So I'm going to say 0.19 for blue. How many people own a cat? Event B. 0.21. 0.21. So all of blue is 0.9. All of green is 0.21. How many people have both?
0.11.
That's what I'm going to fill in here, right? Or they have both. 0.11. Now, what am I looking at? The probability that someone owns a dog or a cat. So what region here will I be focusing on? A and B. So am I shading all of A and all of B? No. Because or, right? This is an and, correct? So I want to look at what is this probability and what is this probability, right? Does this tell me the probability people own a dog or a cat?
Mm-hmm.
Okay, so we got to figure out these values. How do you think we can figure out, this is why the pictures are important. How do you think I can figure out how many people own a dog but not a cat? Subtract. Very good. So dog is 0.19, and I'm subtracting that from people that have own both, because I don't want to know people that own a cat here. That gives me 0.08. Okay. So I will say here that 8% of the people own a dog but not a cat. Correct? Okay. Now what do I do to find people that own a cat but not a dog? Just a cat. Subtract. Very good. So cat, I need to take how many people own a cat, subtract that from those that own both, and I get 0.1, right? So that tells me that this region here is 0.08. This region here is 0.10. How do I find the probability that someone owns a dog or a cat? Add them together. 0.18. 18% of my people that I surveyed here, or whatever, own a dog or a cat. They do not own both, or one or the, or yeah, they own one or the other. A check of dorm rooms on a large college campus revealed that 38% had refrigerators, 60% had TVs, 20% had both a refrigerator and a TV. What is the probability that a random selected dorm room has a refrigerator or a TV, but not both? So let me give you a minute. Let me have you try to figure this out. What's the probability of my blue here? Somebody having a refrigerator? 0.38. I'm going to call my green somebody having a TV. What's the probability of somebody owning a TV? 0.6. Now, them having both is what probability? 0.20. Now the question asks, what is the probability that a random selected dorm room has a refrigerator or a TV? So they do not have both. They have one or the other. So again, I'm looking at this shaded region here, right? So to find just this So to find just this shaded region of my blue, I need to subtract 0.38 by 0.2. So fridge is 0.38 minus 0.2, and you get 0.18. Again, please keep these in probabilities and decimals. We're not thinking of percentages as far as answers just yet, because we're going to be using these decimals later. And then with TV is 0.6 minus, because I don't care for this region, 0.2. Did you get 0.4?
Mm-hmm.
All right. So what is the probability of having a refrigerator or a dorm room? 0.58. What say you? Everybody else? Yeah. All right. Last rule for today. Suppose we're looking at the multiplication rule. Suppose your job requires you to fly and the airline reports that your flight is on time 80% of the time. What is the chance that it'll be on time 2 weeks in a row? That's the same as asking the probability of being on time this week and next week. So last problem, addition rule was an or. Now let's look at an and. This happens and this happens. The multiplication rule says that for independent events, to find the probability that both events occur, we just multiply the probabilities together. So notice independent events is next week's plane dependent on whether this week's plane's on time? No, they're separate independent events. That's what that means. So for two independent events, A and B, the probability that A and B occur is the product of the probabilities of the two events. So notice how this union is flipped upside down. So if you see this, this is an and. You can just almost write an A right here, right? Or a line, make that an A. Grand. We are multiplying. So an or problem adds and problems, so these are keywords, and both, we're going to multiply. That tells me multiplication is coming. A student figures that he has 22% chance of being let out of class late. If he leaves class late, there's a 70% chance that he will miss his train. What is the probability that he gets out of class late and misses the train? So, is him missing the train, or is the train leaving without him based on the fact that he leaves class late? No, the train's going to do its own thing, right? All right. So, he has a 0.22% chance of being let out of class late. And if he leaves late, there's a 70% chance that he will miss the train. So these two events have to occur at the same time. Late, and he happens to miss the train. So, we multiply. What is 0.22 times 0.7, somebody? 0.154. All right. So essentially, he has a 15% chance of being let out of class late and missing the train. You are dealt a hand of 3 cards. So I have 3 independent events. One at a time. Find the probability of each of the following. Remember, I have 52 cards total. There are 4 kinds. So, actually, I should have flipped this. There are 4 kinds: hearts, spades, clubs, diamonds. And there are 13 of each kind. So that's what's happening. There's 4 of each: hearts, spades, and then 13 kings, aces, jacks, etc. What's the probability that all your cards are hearts? So we have a total of 52 cards. I'm being dealt 1. What's the chance of that first card being a heart? Can somebody tell me the ratio? First off, let's start here. How many hearts are in each deck of cards? 13. Very good. And what's the chance of me getting a heart first time around? So if there's 13 hearts, 52 cards, what's my probability? Very good, very good. I have a 13 over 52 chance of getting hearts first time around. So let's say I got a heart, right? First one is a heart. 13 over 52% chance. So now a heart is gone. So this number becomes a 12. And what does this number become? 1. So what is my chance that the second card I get is a heart? Very good. 12 over 51. So my second card is a heart. And I have a 12 over 51 chance that that happens. Now, what's my probability that the third card is a heart?
11 over 50.
Very good. 11 over 50. Now, this needs to happen. And this needs to happen. And this needs to happen. So what am I doing to these fractions? Multiplying. And what does that equal, somebody? 0.0. What'd you get? Nobody else? Nobody's going to check my work? 1.3. Anybody else get a 13%? Oh, sorry, a 1.3% chance of that happening? Yeah. Okay, good. So you have roughly a 1% chance of getting 3 hearts in a row. Now, I'm going to give you a moment. See if you can figure out what is my probability of getting no hearts. We said that given that there are 13 hearts in a deck, then there must be 39 cards that are not hearts. So what is the probability of my first hand not being a heart?
39 over 52.
Very good. 39 over 52. That's my first hand. So now a non-heart card is gone. What's the probability of the next hand being a non-heart?
38 over 51.
Very good. 38 over 51. What's the probability of a third card being dealt is a non-heart?
37 over 50.
Very good. 37 over 50. Now I need the probability of this happening, and this happening, and this happening. Therefore I'm doing what? Multiplying. And that equals 0.4413. Okay. 41% chance of me getting no hearts with my first 3 cards.